Hello everyone, this is Bradley. This animation that you're watching was requested by someone, and the reference comes from Cinema 4D. The physical triggering of this animation has been talked for many times on my channel or other people's channel using animation nodes. It's very trivial. The issue, however, comes from radial fall. One thing I have to address at the beginning is that animation node has no radial fall at this moment. There is potentially some non-procedural unpleasant workarounds which I don't recommend you to try because it's too complicated to talk about. Thus, it means to achieve the effect of the reference seems impossible at this moment. So this is the thing that you need to recognize. However, there is a way to achieve this animation very easily without the need of radial fall. So let's start. So the actual principle is very simple. So let's take a distributed matrices. And let's take a 3D viewer. I'm going to change the type to the circle because this is the only way how it will actually work. And if I take offset the matrices and take a location, if I change the Z translation down, all the matrices have been moved up. Then I'm going to do a thing, basically float range and combine vector. I'm going to change the type to stop because I think it's easier to see. If I put the matrices into amount, so I link the amount upstream and downstream through this get list length. And I put the list into vectors, vector into translations. So now you can see there's a gradation of translation occurs on each vertex of the circles. And this is our radial fall. So you can see this radial fall only works in such a circular patterns. And we're going to make it more kind of a radial or spiral shape later. But this is how it works at this moment. So the question is, okay, we now have a gradation, but how can we actually rotate this? It's actually very simple. You just take a shift list. And by changing the amount, you can see this is how it works. Very simple, very straightforward. The next thing that I need to do is to make more kind of spiral distribution using this radial fall. I'm going to basically shift the D to duplicate these distributed matrices and change the type to grid. But I'm going to use this grid for a linear pattern. There's essentially a reason that I don't use linear most of the time. Basically, I've never used linear because it's not actually easy to work with. So let's just change the certain amounts, like make a 6 should be enough. And we can, so let's just keep it as simple. And I'm going to replicate matrix. So I'm going to replicate our linear matrix on each vertices of our circles. By doing so, what we will eventually see is this is the shape. And we can change the radius definitely, so that we have such kind of pattern. And up to this moment, you can see because it's replicated based on the vertices of our circle, so the radial fall has been inherited on this setup. And let's take a transform matrix and axis rotation matrix. Axis rotation matrix is just another way that you can rotate the matrix. So let's use the degree and rotate for 90 degrees. And I think this is good. I think this is the direction of the rotation is not preferred. It goes counterclockwise. I want it to go clockwise, so let's start at 1 and stop at 0. So now it looks kind of nicer. I mean, you can do whatever you want to decide the direction. The next thing I'm going to do is to replicate matrix again. And let's use the distributed matrices again. I'm going to replicate, wait, what's the original matrices? Yeah, original matrices is based on Y. So let's make a 3 division on Y. So now we have 3 replicates. And if we change the length to small amounts, then they are compact each other. And in this case, what we can also do is take offset matrices, and you can animate the movement on Y. So this is one way that you can potentially do. So let's just add a something. So like 1.5, yeah, it's kind of good enough. And finally, the next step is about how to deal with the instance object and triggering the physics and so on. So let's instance object. Let's take an object instance and object matrix output. Put the matrices into instances, object into object sockets, matrices into matrix. And let's generate our cube. Select our cube and goes to edit mode. Just scale down its size. Make sure they do not really overlap. Something like that is kind of good enough. Let's also select add a plane, rotate 90 degrees and scale up 50 times so that it covers. And let's disable our cubes so that I would not say that again. I'm going to animate this translation, and I'm going to use our controller. So let's take an objects transform input, select our controller. This controller is basically just an empty, of course. Be aware that you need a trigger, and it's so originally the setup is in T panels, but now everything has been moved to M panel in the section of node tree. I don't know why, but it happens. And I usually disable the always because it will burn my computer. And in order to make sure the transform of my empty will update the node tree, you need to add a trigger, either the collection or the objects, whichever way you want. So you can copy all this script, whatever. So now let's just hit eyes to add a keyframes like 1 point. And let's take a hit eyes to add a keyframes. So this is one cycle. And this part is done. The second thing that we need to do is to add the cutters. The cutter is actually very easy to work with. You just use our most initial linear matrix and use the spline from points. Put the vectors into points and the curve object output. And you don't necessarily to see everything very clearly, but it does exist like this tube. The reason that you do not see that very well, wait, no, it actually sees very well. And you can elongate this spline object by extrude it. So let's take 0.2 or 0.5 and extrude that so it's more kind of knife instead of a tube. Or you can use the bevel objects. So you can use the bevel object as well. So more if you're using bevel object, it can potentially make more interesting shape, like the more sharper or something like that. Or you can actually turn down the bevel resolution so that it gives a sharp edges. These are essentially ways that you can potentially work, but you know, these are just ways that you can potentially think. Whatever. If by any chances your orientation of this entire thing is not right, then you probably means you need to tilt that. Like tilt half of pi or something like that. But it seems okay here, so I'm not going to bother. Rotation of this cutter basically requires, so again, there's a transform vector. You can also transform spline actually. Whichever way you like, does not really matter. And it's possible to just use axis rotation. And I think it's select Y. And by changing this Y, you can actually cut this entire whole thing, which is actually very cool. So here's one thing, if you enable the replicate in the matrices, you can see there is a difference between so the cutter is not long enough to cut all these objects. The reason is because we have a radius offset. So this is one reason. But if we make the radius to 0, you can see all these points all these cubes has been staggered together and forming very round geometry. And I use a very bad method in live noding, and later I found the best method probably is just to slice the list. So I'm not going to input the first point to anything downstreams. And secondly, you can see the second point is also not very, the last point is also not very long enough. So I'm going to slice that list as well. So let's take that to 5. So now my cutter is finally longer than that. So this is one way to work with this entire whole thing. So here what you can do is take an integer input and take a float math. And I'm going to subtract 1. So I put integer to here. I'm going to take the type into step. And I'm going to set the integer input -1 to the end, so that no matter how I change these values, the slice list will be updated very well, that the last object within this list will always be sliced, not included for the replication, but it will be included for our cutter geometry. And by doing so, you finally get what you're looking for. And I think this is a very easy way to work for this entire thing. So now we have the cutter, and this is basically done. You just use the axis rotation to offset the cutter a little bit, and finally to rotate the cutter. The last thing that I'm going to do is to trigger the physics. I've discussed the similar concept in various tutorials for many different times, but I'm going to repeat it again. So I'm going to disable the hidden, and within the mother object, I'm going to add a physics. So add a rigid body, and I'm going to, let's also add a material in case we're going to go back. So I'm going to copy full object so that the rigid body will also be updated into our object. And you can see if I turn on this copy full object, instantaneously all the animation has been disappeared. The reason is they just falls on the ground. And then you can also enable the deep copy, so that each object has becomes independent. I don't know if it will actually change a thing at this setup, but usually I just enable that. Next thing is I'm going to take object attributes output. I'm going to right click the animate options and copy data path and put objects into. Here everything is a Boolean input. So if I take a Boolean input and let's check this Boolean, then you can see animates option also has been checked. And now even if I goes to the frames, then they will only move according to the transform data which has been driven by my controller, but they will not fall down with the physics. But if you not enable that, then immediately it will just fall down with the physics. So this is how it works. Next thing I'm going to do is to generate a for that control this Boolean input to make sure whether this box is being checked or not. And I'm going to use, so let's take a directional for, but many times I'm actually confused with this directional for, so it would be better if I'm using a visualizer. So here the white part means a value of 1, and I will assign to the other side. And so here is a yes or no that you can potentially see on this plane, and I'm going to take a value to 4. I'm going to evaluate matrices and put that into a list. So matrices into matrices, 4 into 4. I'm going to put the visualizer not a thing. And you cannot directly put the strength into values. It will mention the wrong type. Actually, you can. So let's see what actually happens. Yeah, it actually works. So now physics has been triggered only when it moves over a point that has been assigned with this directional for, which also means the back region of this visualizer. So with our initial claims, you can see this is how this setup has been worked out. So this is basically done. There's a final wrap up. By the end of the day, this turns to be a mathematical issues about how you're gonna to translocate all these cubes and asking our splines to rotate for a full cycle. So here I'm going to take another transform vector, link these two translations together, and I will explain why I'm doing this. And here let's just not to use anything. I'm going to link these locations to the angle. It will automatically separate the vectors, and because we're animating the y-axis, so I think adding y-axis is the right way to go. And I'm not going to use the degree, but use just the normal angle. And see, yes, if we're animating the z, you can see this is how things has been go. Here you can see the angle actually goes to an opposite direction as the rotation of our cutter. You just take a float mass times -1 so that it goes the same direction. And here you can still see the cutter is running very slow compared to the triggering of the physics. But this finally turns to be a mathematical issue about how long this cube should be and how fast this cutter should move. And I'm not going to cover all this math, or actually I don't even actually understand all math. But something it's just how it works essentially. And feel free to play around with this setting. Another thing to mention is you can see in my setup is actually more kind of a spiral cutter and a spiral setting. So how have I done that? The thing I've done is actually very simple. It's basically to deal with some effect with our linear matrices at the most beginning. So I take the offset matrices, and I'm going to hit M panel, and in advanced setting, change the global axis from local pivot to global pivot. So basically now this node is equivalent to transform matrices. So this is the difference. I'm going to type the rotation and put a float range. Change the type to the start and stop. Put that to rotation. It does not work, so let's combine ruler. I think switch to Y. Actually it does not work, so let's switch to Z. So now you can see it actually work. So by doing so, you can rotate that as much as you can, and you can rotate the whole degrees. But just be aware that if the more you do, then the low resolution of our spline is. There's also a way to solve that, but I don't want to go too much details about how to solve it. So like this is the way how you can essentially work on this setting. So this is it. I hope this is not too overwhelming. This setup does not even involve a loop at this moment. So I hope this is not too complicated. That's it. So I hope you enjoyed this tutorial, and I'll probably see you next time. Bye bye.